We avoid using any 3D models and instead focusing on what the observer actually sees.
Steven Alonso, you are the winner again. You get the trifecta. You won all 3 TFE challenges.
Of modeling this concept, and someone else actually put it into a 3D render.
Yeah, Steven Alonso. He done from the Trackers app on Google Play.
Jarski says, aware of Glyphs on Ice Blu-ray being sold by Dr. Alonso.
If you go to the posts of my YouTube channel, you'll see the magnetic field that we're talking about. We see that Earth has a toroidal field strength, but let's not even get there yet. We're only mentioning this because Jaren and MC Toon had a live stream recently where they talked about this, but conveniently forgot to mention the north and south field strength. So what we show is the measurements that they did. So Miami, Atlanta, Minneapolis, Santiago, Punta Arenas, and Union Glacier. But they did not actually let people know what the north and south field strengths are. The reason why this matters is because they're different. It's very different. We don't see that beautiful symmetry that you would expect if Earth was a ball. On opposite sides of a ball, much like how the star trails work on the globe, that symmetry has always been an argument for, okay, yeah, we must be on a ball. But when you apply it to stuff outside of just the sky and start talking now about the surface, the whole symmetry argument falls apart. So we see that the North Pole has a magnetic field strength of 56,900 nanoteslas, while the South Pole, 54,400 nanoteslas. So I'm not sure if you can see this, but I'm going to post the actual photo up on the video so you can see. And that matters. And if you watch Jaren and MC Toon's live stream, you see Jaren actually ask MC Toon about the North and South. Are they equal? And you find MC Toon had to kind of dance around the question and kind of avoid mentioning it. Well, now you know why. And it's hard to catch that stuff, especially if we just don't know much about the magnetic field strength. If you listen to that, it does sound like a convincing argument until you find out that we actually have a toroidal field radiating out of the North Pole. And because of that, of course, the North is not going to be equal to the South. But if we were actually on a dipole, on a ball, it would have to be equal. So that's my argument for why the magnetic field strength on flat Earth makes much more sense. And then as a side tangent, I wanted to point out the deception that MC2 did to Jaren. I think Jaren's in the right for this one. I don't think Jaren actually knows enough about science to know off the top of his head the difference of the field strength. He would just ask someone like MC Toon, assume MC Toon's going to tell him the truth. But this is a really good example of how someone like Jaren, who might have good intentions, is being deceived by Globers. So watch the live stream and go to the part where he asks MC Toon about the North and South, and then ask yourself, why did they hide that measurement? Why would they show Miami, Atlanta, Minneapolis, Santiago, Punta Arenas, Union Glacier, but not the North and South Pole, when they're using the World Magnetic Model? So that's how I looked it up. Like, we know this data. And when you plot it, it ends up being a toroidal field. You don't get anything of what the globe would expect. You get exactly what the flat Earth predicted. So for that experiment, we now know, based on the magnetic field measurements that they did, they also validated these calculations as well. We now know that the Earth must be flat. And one cool thing I want to actually let you guys know, go to the Compass app on your phone, and for a lot of you guys, it'll actually show you the field strength in the bottom corner. It's super, super cool. So you can now test predictions that the flat Earth model is making in real life. So for me, I live in Belize, and it's showing 38 UT. So in the image that I showed before, we're talking about nanoteslas, but 37 UT is equal to 37,000 nanoteslas. 37 microteslas is equal to 36,000 nanoteslas. But the whole point, just pay attention to those first two numbers. That's all that matters, because you're trying to see how, if you graph it, how it would have to form a toroidal field. And when you understand that yourself, it's really, really cool. So test this out yourself. I'm telling you right now that I live in Belize. My latitude is 17 degrees north, and my field strength right now is 37. Now test where you live, and are you farther or closer to the equator? So if you're above me, you might have a stronger field strength. If you're in Minneapolis, your field strength would be stronger. So this is super, super cool. And they didn't really talk about it that much. I'm trying to tell you guys how you can go out and test it, but also the real flat Earth prediction. When you look at their slide, they, again, this was intentional deception, but it's by MC Toon, not Jaren, but that it radiates outward and decreases with strength. I'm not sure any flat earther who makes that claim, and if they haven't been able to quantify it. It makes no sense, and it's very easily disproven. We know that it has to be a toroidal field, and I'm sure everyone's familiar with that type of geometry. The South Celestial Pole absolutely exists on flat Earth. I believe the confusion people get is that they've never seen it with multiple observers, because you can't do that with the globe. For example, a stellarium, you'd have to have two separate windows to do it, and then you still can't zoom out to see what it looks like from the bird's eye view. At the moment, the globe is still trying to catch up to where flat Earth is. So the best globe model that lets you zoom out only has one observer. It's the Dr. Marsh model. So with flat Earth models, we can now plot two observers and then see that, okay, yeah, the flat Earth model does require South Celestial poles, and it works just like how we would expect. So with dome refraction, we only ever have one physical object at a time. It's on the firmament, shining through, and for the observers, that's what they end up seeing. A very good example of this will be, let's imagine there's someone here. This person here, they see the Southern Cross, and as you know, it's a collection of 4 stars. So let's say the cross has the top part above them. So it's like the long thing, and there's the top part here. But what if we now have another observer now on the opposite side? Their back is to the other guy. They're both facing out, so southwards in an infinite amount of different directions. So one south there and another south there. But now that it's been rotated by 100 degrees, the observer is now seeing the Southern Cross also rotated 180 degrees. So the bottom part is down here of the cross. So one observer sees it with the top part, the other observer sees it with the bottom part, because the light is shining through the firmament and refracting through. You can test this actually with globe software to see that what I'm saying is true. This is a claim that we all believe, both flat earthers and globers. We believe that this observation is what you'll see. Now, how it works is something that not everyone knew about. If you weren't aware of dome refraction, it would be very confusing as to how can people be looking in different directions with their backs to them and somehow still see the same thing. But it's not actually the same thing. It's rotated depending on what part of the firmament you are looking at. That's extremely important to understand. Globers, They don't want you to know that. So when you look at the material released by globe propagandists such as Professor Dave, you'll see that in his photo, he shows that the Southern Cross would be the exact same orientation for all the observers. Either he's trying to deceive you or he doesn't know better because globe models can't do multiple observers. So it's hard to tell whether people who promote the globe genuinely just don't know any better because globe science is still far behind and they can't do what flat earthers can do, or if they actually do know better and they're just trying to deceive you, because there's no reason like someone like Professor Dave can't afford the $20 a year academic subscription for proper astronomical software that lets you plot multiple observers. So I don't know. You come to your own decision whether they're trying to deceive you or not. But the truth is, when you look at how it works with a real life model, you see that the flat Earth model requires a south celestial pole, infinite of them, because longitude is a continuous coordinate system. Does that make sense? You can go an infinite of places around there. The example is 0.001 degree is a very, very different position than 0.00001 degrees. So you see what I mean? There's an infinite. It can rotate as much or as little as you want, depending on how much you move. So we covered now the magnetic field strength and the south celestial pole. We're going to now discuss the 24-hour sun, the 24-hour moon, and the sunrise and sunset times. Right now, let's take a look at the 24-hour sun and moon. We're going to discuss them together because there's no real difference between the concept of how it works. Even if we were to take a look at the stars that make up the Southern Cross near the South Celestial Pole, you will find that the mechanism that allows the 24-hour visibility to be there for multiple observers is the exact same thing that happens with the 24-hour sun and the 24-hour moon. So all of this comes down to our fundamental understanding of cosmology and celestial mechanics. Do we know how the basic concepts work? Yes or no? So with the sun and the moon, it's very, very easy, more so for the sun, because the path that it takes doesn't change that much. Above us on the firmament, we know that it's going around in a circle, so much like on the map of our world, we know it's going around, so it would be that way it's going around. That all makes sense. Now the sun is shining through the firmament, and this refraction that allows the light to come out is what happens in a parabolic dome. Much in the same way as how if you're on the beach, for example, watching a sunset, and you know how you get the ray of light, like right coming up to your feet, but everyone gets that. So you can be on the beach with your friends. All of you are looking at the sunset, but each of you have your own personalized ray of light coming up, and you cannot see the other people's. This is how we know that what we're saying is true. We have to live under some type of glass, plastic. We don't really know what it's made out of, but we do know that we live under a dome. That's very easy to understand. There's no real other way for us to have these types of optical properties. So this is the dome refraction. We find that our optics of our sky work through this dome refraction. Now, to determine whether there would be a 24-hour sun or not is something different from the physical mechanism that allows that to happen. Now, I just gave you the physical mechanism for how that would happen, but I could be wrong. We may figure out other better mechanisms. Perhaps there isn't a firmament. Perhaps the firmament is flat, and like we don't know, so we can still learn about that. However, the flat Earth prediction of a 24-hour sun will never change. The flat Earth model will always require a 24-hour sun in the South Pole, specifically when you get past 67 degrees of south latitude. So how would we calculate that ourselves? How do we make a flat Earth prediction? It's really not that hard. The 24-hour visibility formula applies for all celestial objects. Now, why does the formula work for all objects? Well, if the Earth is flat, it makes sense. They're all the same distance apart. They're all on the firmament. We don't have some stars that are 1 million miles away and then some that are 10 billion. The globe model, the heliocentric cosmology, is ridiculous and doesn't make that much sense. Ask yourself why the 24-hour visibility formula works for all celestial objects. It doesn't matter whether it's 1 million miles away or 25 billion light years. Why? To me, it makes way more sense on the flat Earth because all the stars are the exact same distance apart. They're all on the firmament. It's that distance away where we don't have the complex heliocentric cosmology where you have like a space that you can travel through. For us, on the flat Earth geocentric cosmological model, all the celestial objects are on the firmament. And that's why the 24-hour visibility formula makes more sense to be applied on a flat Earth. So for a glober to then make a prediction using this formula, they have to then justify that 90 degrees. That 90 degrees comes from the zenith of an object, that's straight up above you, and then the horizon. So that's 90 degrees. We're measuring Earth flat for this formula to work. If Earth were a globe, you would then have to do about 89.9999 degrees. But how come they don't do that? How come when I do exactly 90 degrees, people tell me it's globe math? But that's not. You understand the problem. So to reiterate, the 24-hour visibility formula is you take the absolute latitude of the observer. For this case, we're talking about Union Glacier, so that's 80. And we need to determine whether it is greater than or equal to whatever 90 degrees, subtract the absolute celestial declination of whatever the object is that we're trying to track. The celestial declination is just a sky coordinate. It's a fixed place in the terrestrial sphere that we know where an object is relative to any observer. These are still the flat baselines, local. Even on a globe, we're still talking about the tangent to a curve, the infinitesimal flat measurements that are indistinguishable from flat Earth, except when you actually start applying it in real life, you then need to justify why you're using 90 degrees. Why aren't you going to use 89.999? Are we on an oblate spheroid or a perfect sphere? So the globe starts to fall apart when we actually make predictions. And I mean by showing with the math how we know there's going to be a 24-hour sun on either flat Earth or globe. It's not as simple as just holding up a globe and a sun and moving it around and saying, sure, because that's not a model. Like, the globe has no real model, and they can't justify their claims that way. So we can test it. So how would we make a flat Earth prediction to see whether or not there'd be a 24-hour sun at Union Glacier? Well, The first part we already discussed, that's 80 degrees. Then the second part was 90, subtract 23, that's 67. So then is 80 degrees greater than 67? Is it true? The answer is yes, which means we would have a 24-hour visible sun if we're at 80 degrees south latitude, which is Union Glacier, if we're also there in December, which is when the sun has that declination of negative 23 degrees. Does that make sense? So you can apply this to any celestial object as long as you know its declination. Declination is a sky coordinate, and all that it means is how far up or down it is on the firmament. So imagine you have, actually I can just explain it really well. So the declination of negative 23, you're going to be lower on the firmament right over the Tropic of Capricorn. Because the Earth is flat, you're always going to have a one-to-one mapping of the sky coordinate to the latitude. And I'm being very serious about that. So the sky coordinate of declination is always going to be exactly equal to the latitude of the ground position. So if the sun has a declination of negative 23 degrees, that means it has to be at the Tropic of Capricorn, because the Tropic of Capricorn is negative 23 degrees. Does that make sense? So this is how we, like we know where the sun is, because you just go outside and look, and now you have the sky coordinate, because you're looking at the firmament. You're not looking off into space at some heliocentric cosmological model. You're literally looking about 6,000 miles up at all of these objects, and they're all on the firmament. Your angular distance, your vision is the same. It works very well. So then how would you now take that one step further and see the moon? If we know that on flat Earth, the law of perspective applies for all celestial objects, well, for the moon, okay, let's say we're actually at Union Glacier. So let's say we're at Union Glacier and we want to know, will there be a 24-hour moon? Well, we'd have to then look at what the declination is for the moon at Union Glacier at that time. Who knows what it could be? But depending on what it is, we then just run it through the formula and it'll be quite easy to determine. So I'm going to put that up on screen, the math, so you can go over it, but it works for anything. With the sunset and sunrise formula, we properly derived that from planar trigonometry. This means trigonometry on a flat Earth as opposed to spherical trigonometry on a globe. They're very different. So because this formula works, you can also plot it on a sphere. You can always project the flat Earth onto a sphere. You can project it onto many models. But what the issue is, if we can already do this with planar trigonometry from observer measurements, why do we even need to add in the assumption of a sphere? You can find out the sunrise and sunset times for any location on the Earth by only knowing where you are and then looking at the sun. It's very, very simple. We know the path it's going to take. If you've ever seen those grid lines on flat Earth models, that is the path that the sun will take. And these can be represented with basic trigonometric functions. We avoid using any 3D models and instead focusing on what the observer actually sees. This means that at the infinitesimal area we are, it absolutely is measured flat. Those are where the 90-degree angles come from. This can be projected onto a sphere. That is what the globe model does. They measure Earth flat an infinite amount of times and wrap it around a ball. You can do that, but you'll never get away from that first baseline. The fact that we can determine the sunrise and sunset times without having to use any 3D models at all implies that the flat Earth has that starting foundation. This is that observer-centric methodology and measurements that you may be familiar with in all my work. We don't even need to have a flat Earth model to be able to use this formula. This formula is based off of our own observations alone.
Stephen Alonso, you are the winner again. You get the trifecta. You won all 3 TFE challenges.